All right, welcome to another coding session. Let's get stuck into a bit more flow control. Last time we managed to, maybe I can find it here. We managed to write some logic for if statements. We have if and we also have else, which makes me think maybe I should I put a label for else? No, I think, actually I was asking if we should put a comment for else, but we have a label for else. So I think it's fairly clear when there's an else. But we have if and we have else. We can see it in our assembly. I'll try to find a simple example. If so, and here we go. So this is an if statement. You know what? Maybe I should call this if underscore 0, I think. So it kind of matches nicely. And maybe I won't indent it. I was tempted just now to even make it a label, but I think that's a little overkill. I don't think we need to have it as a label, but let's put it like that. Yeah, so because we've got if0 and then we've got if0 end. Okay. So yeah, and it's just obviously there's an expression. This here is evaluating an expression, and then we test that expression. And if the expression evaluates to 0, which we are calling false, then we're going to jump past the scope, which is the body of the if. We're going to jump past it to this end label. If it's not a 0, which means that it's true, then we do enter the scope and just continue as normal after that. So now I'm thinking let's do some else if. Let's try some else if. And I'd also like to try some for loops. And strangely enough, I think the else if might be the harder part. I think the loops are not going to be too bad. But let's see what we can do with else if. So first, I think we need to go to our grammar. Here's our if statement. So it's the token if followed by an expression and a scope. And then we have an optional group here. So we could optionally have an else with a scope. So I think what we need to do is add in here. This one's actually going to be a star. Oh, I think we need the hat to put them up high. And this one is going to have else if scope. So by putting the group, so when I say group, I mean something that's in brackets. It means that everything in brackets can appear with the star 0 or more times. So there could be there could be not an else if, which is what we have now. We have if statements that don't have else if, or there could be one or more else ifs. Yeah, that does remind me of something that I think I would like to have a set of statements as a separate production, but let's not worry about that now. So we don't have any new tokens. We already know about else and we already know about if, so our tokenizer doesn't need to change. Our parser does need to change to handle this this part. Recently, the parser has been really nice to work with, I have to say. Let's find out if. Exit, assignment, declaration, scope, if. Yeah, it's been really nice to work with because we added this peak token And next token, we've added some nice token streaming, which has made it really concise and easy to work with. So now we're going to do 4, actually. 4 else. And we're going to say, so we consume the else. And then we're going to pick the next token and see if it is another if. And if it is, then we need to do another expression, don't we? All right, just a second. I have to pause for a second. All right, I'm back. One of the cats was hanging around, and she can be quite annoying when I'm trying to film. Right. So this is what I added, because we can have the else, but then after that there might be an if, and we need to do some checking to make sure that only the last else doesn't have an if. They all need to have ifs except for the last else. Yeah. So I wonder, so if I try to peek past, then I get end of file. Yeah, I think that was a nice addition, this end of file thing. Although I did realize that this is one place. Sorry, I'm going for a side quest. I did realize that this is one place where we don't have line numbers. Let's not fix it right now. It's a bit tricky because we don't. Yeah, we don't really know, because we don't have. Normally we do them at the start of a token, but there's not actually. Anyway, let's forget about that. But the reason I wanted to check that was because I want to actually go while we have else, and the next one is also if. Yeah. And we never need to worry about this bleeding past into the tokens, because we'll just get end of file back as our token. So that's good. I think that means that if I cut this out and restore the original code, there. Yeah, I think I liked that. So we have a loop while there's else if, and then after that we also check for just an else. Yeah, so at that point we know that it's not else if, but maybe it's just else. Okay, I like that. So we consume the else, we consume the if. And this is the, we'll call this the else if scope. And this is the else if expression. I think that's it. So is this going to give us enough context? What I mean by that is we have an if node, and then inside that we have expression scope, and then we have more expression scopes, and these are all children of that if node. So it's going to go expression scope, expression scope, expression scope, expression scope, and then just a scope at the end. I think that's enough for us to work with. I don't think we need to have any other extra nodes to tell us more information. That's kind of what I was wondering about, but I think that's going to be else and an else if is just an expression and a scope. Oh, I did not put the expression in there, but an else if does need an expression. There we go. Cool. So now we can go straight over to generation. Here's our if. And yeah. Yeah, so this is interesting how we'll end up doing this, but let's say current child node which I think will need to be a pointer to a node because it could be nil. So if we have more than 2 children, then we're going to get the third child, the address of the third child. Otherwise, we're going to say nil. So that should be a node pointer, AST node pointer. And now it's 4 here, isn't it? So again, maybe I'll leave this for now, and we will try to do a loop above it, kind of like what we did in the parser. Let's see what we end up with in the end. So while the child node is not equal nil, that's important. And the child node also does not equal the last node. There might be a better way to get the last node, but here I'm just going to say the address of the last node. So it can't be the last node either, because if it's the last node, that means that it's just an else, right? We have pairs of nodes, and then we have a single node. So if there's an else if still, it means we have a pair of nodes, which means that the current node can't be the last node because there must be another one after. So at the start here, we're going to say if1 else if, and then so I guess we need an else if counter. Else if index. Well, we don't really want to jump to that, do we? And maybe to make it a bit easier here, because you know we're saying like we jump to else or we jump to end. Maybe to make it a bit easier, we're just going to say else index, and this is also going to be else index, and this is also going to be else index. So it doesn't matter whether it's an else or an else if. This one doesn't need it. That one doesn't need it. Here's else index. Else index, that one needs it. Skip else, scope. So this one, what did I have here previously? Skip to the end, right? Yeah, that's still true. We always want to skip to the end. I don't think we need the thing there. Yeah, so, you know, if we've done the if case, or if we've done something before, then we want to skip to the end after that. Whenever we go into one of the if, you know, because if we have else if z plus 77, then you know, we're only ever going to go into one of these, right? So effectively in the assembly here, we want to have the equivalent of this, right? Skip to end, skip to end. Or I guess you could say it's in here, right? We want to have something at the end of here that tells us to skip over both of these. Or if we go into here, we want to skip over that one. So it's always skipping to end. And that's what this is here. So we always have a skip to end before we start processing another else block. The else scope node. So, okay, and these ones we need to do an expression first. We need to do something like this. With the current child node, which is, no, we need to dereference it. Is it this one over here? Yes, to dereference. So here we're saying yeah, if we want to jump to else underscore 0, right? It's always going to be under else 0. We want to go to the first else if there is another child node. Otherwise, we want to go to end. And here, so here we need to know if there's going to be another else. We already need to know, so can I do that? I can't do that with a pointer. Maybe I'll do an index. I'll just do an index. Current child index. So if current child index is less than the length of children, that means we have more to go. And here we need it to be less than the length of children plus 1. Put the else index up there too. All right. So now we go node children, current child index. Just make this a bit shorter, a little less verbose. Then we can increment the child index, right? And now we're saying child index plus 1. So we've incremented it past the expression node, but there's still the scope node, right? So now this is like this. Get rid of that. So skip to end. Now we try our, and if we haven't skipped to the end, so we need this one to be here. I think we need two label. Yeah. So we jump to the end. Yeah. And here is where we go to if we want to evaluate this else. Yeah. So if we're jumping into this else, we come in here, we generate expression, we test the expression, and we skip the else scope when false or 0. And where we skip to depends on whether we have more nodes or more children or not. And something else I'm just realizing is that this is where we need to put an index as well. Looks a bit crazy, doesn't it? So it's the index of the if and the index of the else. But that's only if, like this underscore index should only be there if we're going to an else, not if we go into the end. So it's a little more complicated. And I'm starting to feel like it's too much to go on one line. Strings.concatenate. Because now we need to do like a concatenation of else underscore. I think we need to go like this. And the index, that's right. And this is where, it's a bit of a pain in the ass doing this actually, in Odin, I have to say. Because now we need like some buffer, which I'm gonna hugely oversize. And then the strconv I to A. Yeah, we need to pass in the buffer and the number, which is the else index plus 1. I guess we can go else index plus equals 1 there. Yeah. Oh, I think it's a slice that we need. And that can just go straight into there because it returns a string. And that's like our else with index. This feels a bit messy to me, all this stuff, but here we go. Else with index. Then we don't need this. Yeah, because end should not have underscore index afterwards. Let's see. So basically we're saying if we jump into, here's our label. So we jump in, we perform our expression, then we do the test of that expression. And if the test evaluates 0, then we need to either jump to the end or to the next else if there is another else. And then we jump else, generate our scope. And we keep incrementing the child index as we go. We increment the else index. Yeah, so this should do it for all of our pairs. And then we can also say, you know, if child index is still less than the length of children, then we do our regular else. Which does not have any of this expression evaluation jumps to the end. We do need to have this guy here. Be just for consistency, we'll put that 2. So it's a label for this else, which we had put here. Yeah, it's exactly the same. And then we generate our scope, which is with this guy here. Do this. These increments are not really necessary at this point because we're never going to use those indexes again, but I don't know, I'm just doing it to be consistent with the incrementing we're doing over here. I think that should be about it. That actually wasn't so bad. How long has that taken us? 25 minutes to implement that. So that should be false. That should be true because Z is 77. Yeah, Z is 77. So 77 minus 77 is 0, which we are calling false. So that will not execute. This will execute. We'll give that 42. And this should not execute. So we should get the answer 42. Let's compile that. Ooh, index out of range. Child index. Oh, I think that should be -1. Yeah. To account. So that's, yeah, that's accounting for the fact that we. So maybe it's actually better to write it like that. Maybe that's clearer. Child index +1 should still be less than the length. Yeah. There we go. So if 0, if 1, if 1 else 0, if 1 else 1, if 1 end. Cool. So if 1 is getting our variable, it's getting 77, it's subtracting one from the other, it's doing the if test, and if it finds that the result is 0, then it goes to if 1 else 0, which is down here. This should be what it does. And then we also get a variable in 77, but this time we add them together and we do the test. And if it's 0, we go to if 1 else 1. But that shouldn't happen in this case. In this case, we should go in here and assign. So we move 42 into R8, then we move R8 to our variable. So we're assigning 42 to our variable. That's that line there. And then we jump to if 1 end. So we don't do this. We skip down to here. Okay. And we turn with our result of 42. Error symbol dot start underscore start dot f underscore 0 underscore n underscore 0 not defined. Okay, so I think my understanding of these dots was not correct. No, but we've been using dots before. So what's it looking for? If 0 end 0. Okay, because it's if 0 end, and it's looking for if 0 end 0. Yeah. So we did not put. Let's go back to generation. There should only be one end per if. So this is again, our else needs to have underscore 0. But this time we can just do it like this. Should be like that. Yeah, so now it's going to if 0 end. Okay. There we go. 42. Nice. So we're going to try else if. Nice. And we can say, so result is 20. So if I say else if result minus 20, that's also going to evaluate to false. Maybe I'll make that minus 77 as well. So all of these should evaluate to false. And it should go here and we should get 9. Let's try that. One thing we're going to have to do one of these days, I'm kind of avoiding it because I don't enjoy doing it so much, but we're going to have to, ooh. Because result is actually 0. Result is 0. I've been playing with result too much. Nine. Yeah, that's what I expected. Crap. What was I talking about just now? Oh, yeah. At some point, we need to create a test, an example file. I think first we need to implement some sort of assert. And then we need to make a test file that just tries all sorts of different things, creates different variables, does different expressions, does different branching, looping, all sorts of things, and just has lots of asserts so that we can assert so it's basically our tests, right? Just to verify that our language is working properly. Then whenever we make a new feature, we can add some new tests to the file, run the file, and if none of our assertions trigger, then we're good. That would, now that I say that, that sounds pretty nice. We should do that. But all right now. 43, so maybe we'll just test going to like a second else if. Why not? And that went to the second else if. Cool. I'm pretty happy with that. One thing we can also do, whoa, what about this? If one, so if true. We'll be quite boring with the conditions, but I want to go else if else so we go result is 43, result is 44 and 45. So that should evaluate to true. That's false. That's true. We should get 44. Oh, okay. So our nested inconsistently redefined. We're redefining labels. So we've got if1, and then we also have another if1. Okay. So, okay. I think I know why. I think I know why. Because in our if we have this if index, right? And we use it throughout the whole thing. That's great. But what if when we evaluate one of these scopes, we do another if, right? And we haven't incremented this yet. We increment it right at the bottom. So if there's an if in here, it's going to use that same if index. If there's a nested if in the scope. So I think what we need to do is just make a local copy of the if index, and then we can increment the one in the context straight away. So then just try to find all these. Don't need that at the bottom anymore. Let me just click on this to see if there's any I missed. Oh, that's on the scope. Yeah. So now we should be using a local copy of the if index. And whenever we go into a nested if, we should be good. Ooh-wee. Yeah, now that's if 2. So within if 1 else 1, if 0, if 1 else 0 else 1, if 1 else 1, within if 1 else 1, we have if 2. With an if 2 else 0 and an if 2 else 1. Very nice. So does it give us the result we were looking for? 44? Yeah, that's the one that I was thinking. Great. Nice. And if I make that evaluate to 0, then we should get 45. Nice. Okay. Wow, that's cool. So we have if, else if. That's really cool. Okay. All right. We're 36 minutes in. Let's see if we can crack out a 4. 4. And so we're just going to do a real basic one, right? So this is going to be for expression scope. Oh, where did we need the token, right? We need the keyword for expression scope. So essentially it's a while loop. I'm calling it for just like Odin does. So like this is a while loop, but they just use the keyword for. So there's only one loop keyword, for. And I like having less things. So just one keyword for looping is good. So we're essentially just implementing a while loop. So in our code, we should be able to go for index. We'll just say for index, because I was going to say for index greater than, but we don't have comparison yet. So we've got index 0, no, index 10, sum 0, index 10, and we'll go sum. Wow, is this actually going to be, no, we can't do that yet. We can't do plus equals, but sum equals sum plus index, and index equals index minus 1. And then we can return the sum. So here we start with an index of 10. And as long as index is not 0, we go into here. So sum is 0, so that would add 10 to it. Then we decrement the index, loop around. Now index is 9, so now we add 9 to it. So we should get the answer, which is 10 plus 9 plus 8 plus 7 plus 6 plus 5, 4, 3, 2, 1. That's the idea. That's our test loop. Cool. Okay, so tokens, we have a new token. Well, we have a new keyword, which is quite easy to add. You know how I'm a stickler for alphabetically sorting things. So it would be else for if. So now we have a for keyword, and we need to parse a for. Where did I put it in the grammar? After if. Okay, this is where we need to check here. So if peak token stream dot value equals if, then we do our parse if, else if, which we can do in our language now, by the way. Else if we're talking about for, and because of my silly alphabetical ordering rules, we have to do that first actually, then we do for. But my silly alphabetical ordering rules are overridden by this ordering, which is what I'm going to use when I'm ordering the functions. I am silly, I know. I have my quirks. I will not deny it. So this is a for node. We're going to need to add that. That's going to need to be a thing. For. And let's look at our grammar to see what we do. Expression scope. So that's quite similar to an if. Here we go. I think it's just like that. So we verify that we had for, then we add an expression and a scope. Done. Generation. Let's add our for. This is not alphabetical. I'm going to let it slide for now. We're going to do the order that it is in the grammar. But man, it's just not right, is it? It's just not right. I'm only holding back because you're watching. Okay. We're on fire. We're going to have a for index. We're going to copy some of this stuff. Because the for is also going to have labels, and we don't want to get in trouble with those. Just to be super inconsistent, we're going to go for, no, this one goes below. There is a method, a silly, like arbitrary in my head method to these things. So this is for index. We have an expression and a scope. Very nice. We don't need to worry about all the, see, in a way loops are simpler, right? Because we don't have all these extra crazy cases. We do have an expression that we want to evaluate for our expression node. Skip for scope. And this is just for index end. So we, if the test fails, we just go to the end, we just skip over the loop, basically. So then we have something equivalent of this. Right at the end, we have this for end. So that's what we jump to when we're done. When we're done with the loop, we jump there. And while we're not done with the loop, we obviously have the scope that we generate. So we do all the stuff within the for, has its own scope. And then we have kind of like this, right? This non-conditional jump, which comes after the scope. But this time we're going back. We're going back up. Ah. Interesting. So here, I think we are going to make this a label. Because we want to do the expression again. Right? So we do the scope. And then we jump back up to here. Then we do the expression again, and that determines whether we go into the scope again. I think that's it. I think that's a loop. Let's try and compile that. We've got all our ifs. Okay. Here's our for loop. Here's our for loop. Let's run through this. So that needs to have a colon on the end because it's a label. That's our first error. Oops. Oh, I debugged, but that's fine. Okay, so we have our for loop. We're just checking this variable. That's right, we're checking index. So we test, if it's 0, we go to for 0n, we go to the end of the loop. Great. If it's not 0, we're adding two variables together and assigning them to another variable. And then we are subtracting 1 from a variable, which is, this RSP0 is must be the index. Yeah, because that's what we're testing with. And RSP8 is our sum, which is what we exit with. So we assign, and then we jump back to the top, which we have not formatted correctly, because we are missing the index. Like so. So then we jump back up to 4, 0. So we jump back up to here. And then we do it all again. Looks good to me. Wow, this is exciting. I thought it was going to be more work than that. Maybe we can even get to the a bit more of an advanced one, because at the moment, we're declaring this index here, and then we're doing the increment here. But usually in a for loop, all of that would be in this line, right? So we just need to expand our syntax a little bit to do that. I think it shouldn't be too bad. Okay, so we run it, we compiled it. Okay, the assembly compiled. 55. I need to check if that's right. 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 55. What? Just like that, we have a loop. We have if, else, and loops, and else if. Okay. Let's expand our for then. Let's expand our for. We're on a roll here. So let's put this in a group. I think I keep putting that on the wrong side when I'm doing my brackets. So this is expression or, So it could be just a regular expression. Or we're going to say declaration followed by expression followed by assignment. I'm not sure if that's really right, you know, that it's like so restricted that you have to do these specific kinds of statements. And I'm going to do something a little bit weird here. I know normally it's a semicolon. We don't have any semicolons in our language, and I don't want to add semicolons just for this. So I'm going to make them comma separated. Let's see. Now, I guess the challenge here is knowing if you've got a declaration or an expression. You know? How do you know that? This is where I think our error handling is probably not great, because if we come across, if we come across something that's wrong, we just crash. Because I think what comes to mind is we can try to parse this, and then if we fail, we fall back to expression. That's my thinking. But these functions, when they fail hard. So that's not great. That's going to take a bit of a refactor. So if we go to our for loop here, which looks so simple at the moment. So this is where we want to do like, we want to try and parse a declaration. But we want to have like, you know, like declaration okay or something. This is going to introduce more complexity for sure. You know, if we adopt this pattern throughout here, and we don't have that much time left, so I'm kind of inclined to just like try and work around this. I'm going to say I think I'm just going to do some kind of manual stuff that would not hold up in the long term. So I'll put a to do just to mark it as ridiculous as it is. And then I'm going to say if yep, so we consumed the for. So if peak token dot type equals identifier and peak token dot type the next one. So we're saying it's a declaration, right? A declaration. So declaration has colon equals. So that's enough to know that it's a declaration, because declarations are the only things that have colons. Identifier colon, that's a declaration for sure. We're always parsing a scope, but the question is, do we parse? What do we parse here? I just realized that there is a new token, a comma. We don't have a comma token yet. So where are our single character? Let's put it at the end here. Comma. Comma. So when we're parsing, we verify that the next token is a comma. Then we parse the expression and then an assignment. So that's our expression node. And our assignment node, like that. Okay. Yeah, so I don't like how we're kind of relying on this manual checking here. I feel like a more robust solution would be just to try and parse a declaration, and if it fails at any point, then we fall back to this. Because our declaration the syntax could change. We could get more flexible with how things are. We could have, multiple cases within there. So this check may start to fail in some cases when it shouldn't. Yeah. So I feel like that would be better. Yeah, but we're running close to the hour. We've been doing pretty well so far. I kind of want to just finish this off a bit, and that's going to take too long. Okay, so when we're generating our for loop, we don't know if this is an expression node or not. We do know that this is the last node is our scope for sure. The difference is it's kind of interesting because I guess we want to create these variables, and essentially we're creating them in this scope. This is kind of the same thing we want to do for functions, right? For functions, we want to create a scope, and if you pass parameters in, essentially they live in that scope. That's another thing we're going to need to do better later on. But right now, we're just going to fudge it. I kind of like this challenge that I give myself, where I'm like, I got an hour. Let's see what we can get done in an hour. And if stuff comes up a bit funky, it's fine. It's fine. We'll fix it up later. So here, there's like there's the two cases, right? So if the type of the first child is a declaration, then we know we're doing this case here, declaration, expression, assignment. Otherwise, we're just doing expression. So this is the case we already had. This is our expression business. This is our scope business. So that's all the same as it was. The difference here is that our expression is node 1. And we want to generate a declaration Yeah, when it generated a declaration, I don't know how we're going to delete this variable. Let's not even worry about deleting the variable for now. It's just going to exist in the ether. We're really going to just skip a bunch of shit right now. So this is our declaration node, pass in the context, and sorry, that's child 0. So we've got a declaration and expression. Okay, this is kind of interesting. Like, when does the assignment happen? You know? Because the assignment, we don't want it to happen the first time we come into the loop. First time we come into the loop, we should just be testing index, and index should just stay at 10, right? This, if we have, okay, so let's build it, hey? So we're doing index is 10, index. So this is the equivalent, right? You declare index as 10. This is our check. This is our expression to see whether we should continue in the loop, just saying the index is not 10. And here's our decrement. Assignment. So the first time we come into this loop, we would expect index to be 10. So this should not have executed yet. But every time we come back up, it should execute before we do this test, right? So we do the assignment before we do the test, but we don't want to do it the first time. So this for loop thing actually needs to go here. We declare first. No, that doesn't work either. So maybe the assignment needs to go at the end. Maybe it needs to go at the end of the loop. I think that's right. Yeah, because that's how we had it, right? Let's go. This was our original loop. Let's call that sum 0 index 0. Sum 1 index 1. So these loops should be the same, right? And so this here, which is this here, is at the end of the loop. That's how I did it. So the declaration, then the test, then this at the end of the loop. Yeah. So if we have a declaration, then we do the assignment at the end of the loop. Okay. I'm going to test this even without looking at the assembly. Should have looked at the assembly. So here's our for one end. So do we have anything before the for one? No, 4.1 is the first thing. Then we should have a declaration and expression. 4.1 declare. This is our expression. We should probably have a comment in here to separate those two, but that's all right. I mean, that's right. It's a declare and then, because the declare should be above here. We shouldn't be redeclaring. We're just going to keep pushing onto the stack. You know? That could be the issue. Could be the issue. I feel like we can deduplicate this a bit as well. It's a bit rough. I think we have an infinite loop. Infinite loop. Maybe I've bitten off more than I can chew, you know, I'm trying to rush through this. Let's have another look. So we have this declaration of a 0 and a 10. This is after the end of the first for loop. Declaration of a 0 and a 10. Yep, that makes sense. Same as what we did up there. Then we're checking the 10. We don't need to go to 1 yet. Then it seems like we're grabbing the 0 and the 10, adding them together and assigning it to the 0. And then we're jumping to 4.1 before we assign. This is our decrement. That's a lot of assembly for a decrement, eh? So we're jumping back up before we decrement, which is not a good idea. Here it is, jump to top. That should be down there. That's why we have an infinite loop. Oh, whoops. Where is it? Here. 0 that's not correct. Why would that be? 4.1, well, first we have these two declarations, a 0 and a 10. We're checking against the 10. We are adding them together and moving the result to the 0. Then we are, I believe, incrementing the 10, no, decrementing the 10. Yeah, we're decrementing the 10. Then we're jumping back to 4.1, where we test. I don't know why that's an issue. Why would that return 0? Oh, it's because I accidentally ran this program again. Echo, I'm really trying to do too much here. Echo $? gives you the return code of the previously run command, which in this case is NASM. So what we need to do is just run our program. 55. Okay. Enough. We're done. I'm happy. We have else if. And we have loops. Just with a basic condition and also a convenient for loop. What more can you want? All right. Thanks for stopping by. I think you should probably like this one. I think this was a good one. I think we got a lot done. I'm quite happy with it. And yeah, that's it. Ciao for now.